Welcome to Rama Science World channel. Uh, Hi friends, today we are discussing about a motion in a straight line. So motion in a straight line. So first we are understanding about the motion. So motion is a common for everything. So earth rotates around the sun. We are running, we are walking. So even if your sleep position, our breath is moving. So motion is a common. So now first understand about the term rest. Rest means simply we say that there is no move. So the change does not change, does not change. The position of of an of an object with the time. So that is called an object is at rest position. So rest position. So here the position of the object does not change. So in that case, then that object is in rest position. Okay. So now we discuss this term, that is motion. So this motion means here motion is the change the position, change the position of an object. So with time, that's called object is in position, moving position. Okay. So here let's love about nets. Another thing is rectilinear motion or straight line motion. So an object an object move along the straight line. So here a straight line. Suppose an object, here we take a bicycle. Suppose we say that this is a bicycle. In this case, this object moves along a straight line. Then the motion of the object is rectilinear motion or straight line motion. A straight line, rectilinear motion or straight line motion. Here we are also called as, in this case, one dimensional motion. So one dimensional motion. So this motion is only forward direction or backward direction or upward direction or downward direction. So that motion is called one dimensional motion. In case of forward direction, we take the value plus. In case of the backward direction, we take the value negative. In case of the upward direction, we take as positive or downward direction negative. So now let us know about a reference frame or frame of reference. Frame of reference of reference. So a rectangular coordinate system consists of three mutual, this is x, y and z. So perpendicularly, three mutual perpendicular axes, so labeled as x, y and z axis. The points of interaction of this is the point of interaction, three axes is called origin. So we denote with O. So serve as a reference point. This is called a reference point. So reference point. So the coordinates x, y, z of an object describe the position of object with respect to the coordinate system. Okay, here the suppose we say that it is a object. So in this case, the position of the object describes with respect to the coordinates x. So here y. So from this z. So this is the position of the object described with coordinate system. So to measure the time, we position a clock in this system. Okay, so we position a clock in this system. So this coordinate system along with clock consists a frame of reference. Okay, this is the frame of reference. So once again we are learn this one. So this is the a rectangular coordinate system consists of three mutual perpendicular axes, x, y, and z axis. This is the reference point, that is origin, serve as a reference point. The coordinates x, y, and z of an object describe the position of the object with respect to this coordinate system. Okay, so to measure the time, we position or we place a clock in this system. Okay, this is a frame of reference. Let us now learn about the path length, and displacement. So now discuss about the path length. Suppose this is the point A. Okay, an object move towards B. Another that's object move towards C. So the distance between A and B is 2 kilometers. So the distance between B and C is 5 kilometers. Here the path length, that is total. So an object starts his journey from at A point, from the A point, and ends its journey at C. Here the total distance is the path length. So total distance is 2 plus 5, here 7 kilometers. So the total distance is the path length. Okay, suppose this person or this an object move or take the reverse direction or move in opposite direction. In this case, so that person first starts his journey from A and ends his journey at C. So that person move in backward direction and reaches to A point. In this case, total journey is 7 plus 7, that is 14. So 14 kilometers is the path length. So path length means total. So here the distance is called, the total distance is called the path length. Here no need to mention any direction. That's why so path length is scalar quantity. Here mentioned only magnitude. It does not mention any directions. So there is no need here mention direction. So only mention magnitude. Scalar quantity means the quantity that has a magnitude only magnitude. So no direction. That's called a scalar quantity. So only magnitude. So no direction. So that quantity is called scalar quantity. So now let us now discuss about displacement. So displacement, you must observe the term displacement. So you must observe the word displacement. Simply we say that change in the position. Change in the position. Change in position, that is called displacement. Here so here a person starts his journey at a point, from a point, and move to B first. After that, that person move towards C. So in this case, path length and the displacement is same. So that is displacement also here. So 7 kilometers. So only one direction. So that person take. Okay. So now let us discuss about the path length. Here A. So a person starts his journey from A point and move towards the B point. Okay. So after that he move towards C point. Here the only one direction. Okay. In this case the distance between the A and B is 2 kilometers, and the distance between B and C is 5 kilometers. So his total distance, so he traveled, the total distance is 2 plus 5, 7 kilometers. 7 kilometers is the initially path length. So after that he decided to go back to his original position. So that person takes the reverse path. Okay. So in this case directly see that person move towards A position. So total the distance of his journey is 7 plus 7, 14 kilometers. In this case, total distance is 14 kilometers. That is the path length is 14 kilometers. So here no need to mention any directions. There is only here mentioned the quantity. So that is why path length is a scalar quantity. So here scalar quantity means only mentioned the magnitude. So no direction. That is called a scalar quantity. So let's now discuss about the displacement. So displacement means you must observe the term displacement. Here displacement, the change in the position. Simply we say that the change in the position. Okay. So this person so starts his journey, okay, from A and move towards B. Here the displacement is 2 kilometers. So because the initially person is in 0, the position is 0. After some time he reaches to B. In this case the distance is equal to displacement. So after that that person move towards the C position. So in this case 2 plus 5 kilometers, 7 kilometers is the total distance, that is equal to the displacement. So here path length and the distance, path length and displacement is same, but after that person takes, or after that that person decided to go back to origin position. In this case, so this is the positive value. After that he takes reverse path. So he that person reaches to A. Okay. So here 7 is the first. After that minus 7 is next. Okay. Total displacement 7 kilometers minus 7 kilometers. So original the values of displacement is 0. So but path length is 7 plus 7 is 14 kilometers. So path length is 14 kilometer, but displacement is 0. Here there is no change in the position. So that's why the displacement is 0. So because of this reason, displacement is a vector. Okay. The displacement is a vector. Here vector means mentioned direction and magnitude. So both are mentioned. So direction and magnitude. So okay. So that is a explanation about displacement. Okay. So for example, a position initially, an object initially at position x1. After some time, the position of the object at x2. So this is the distance. So we can displacement is delta x. So delta is the difference. So here this is the delta we called as delta. It is a Greek letter. So difference, that is x2 minus x1. It is the displacement. Okay. In this case, you must observe path length and displacement is same for only one direction. So okay, next point, path length may not be 0 but displacement 0. Okay, so here if you throw a ball in upward direction, so that ball reaches to highest maximum point and returns to the original state. In this case, there is no change in the display, there is no change in the position. In this case, some path length is something, but displacement is 0. Okay, so you must consider that displacement 0 and path length may not be 0. Okay, so only same direction. So this case, the direction of the path length and the direction of the displacement is same. That's why here total distance is the path length, total distance is displacement. Okay. Now discussing about uniform motion. Okay, so uniform motion. You know about the term uniform. Uniform means suppose uniform dress. So in a classroom, all members are wear same dress. In that case, so the dress is a uniform dress. Okay. Similarly, here an object move this path. So that person or that object takes the equal distances in equal interval of time. So equal distance in equal interval of time. So in that case, that motion is uniform motion. So here suppose an object takes in 10 minutes, in 10 minutes an object takes a distance 1 kilometer in 10 minutes. Okay, similarly the same distance, okay, take another journey or another and is journey. Okay, like that. So he takes a equal distance in equal interval of time. So that the motion is called uniform motion. Okay, suppose now let us discuss this one. Uniform, non-uniform. Non-uniform ones, not equal distance he take. So here 5 kilometer in 1 minute. Another journey is 2 minutes in 2 kilometers. So 2 kilometers in 2 minutes. After he does not take equal distances in equal interval of time. So that motion is called non-uniform motion. So that motion is called non-uniform motion. So now let us discuss about the graphs. So here that's graph between the time versus position. Okay, so now we take a position of stationary object. So stationary object means there is no change position with time. So in this case, suppose this is the graph line. So 10 minutes, 20 minutes, 30 minutes, 40 minutes. So up to here at 20, 40 meters, 60 meters. Here we take. So this is 10 minutes, the same position. In 20 minutes, the same position. 30 minutes in same position. So that's why this is the graph of between x and t. Okay, now let us the graph sheet with uniform motion. So here the dist t and here the x. So here that object takes equal distance in equal interval of time. So this is the graph between time versus x. Okay, so thank you.